Imagine this. You are floating alone in space. Ahead of you is a perfect circle of darkness. No light, no surface, no warning signs, just a black void hanging in the universe. A black hole, the most terrifying object known to science. Now imagine something even more disturbing. You're falling toward it, and there's no way back. What happens next? Would you die instantly? Would you be crushed into nothing? Or could you survive long enough to discover what no human has ever seen? The answer is far stranger than science fiction, and it begins long before you reach the black hole itself. For decades, black holes existed only as mathematical predictions. Even Einstein wasn't convinced they could actually exist. But today, astronomers know they are real. They have photographed them, measured them, and watched entire stars disappear into them. Some black holes contain the mass of several suns. Others contain billions of times the mass of our sun. Yet despite their enormous size, they remain among the most mysterious objects in the universe, because no one has ever seen what lies inside. To understand why, imagine standing near a waterfall. Far upstream, everything seems normal. The river flows peacefully, but as you move closer, the current becomes stronger. Eventually, you reach a point where the water is moving so fast that escape becomes impossible. No matter how hard you swim, the waterfall will pull you over the edge. A black hole has a similar boundary. It's called the event horizon, the point of no return. Cross it, and nothing can escape, not even light. That's why black holes appear completely black. They don't reflect light. They don't emit light. They trap it forever. Now imagine you're approaching one. At first, nothing seems unusual. You drift through space. The stars still shine around you. The black hole appears distant and silent. But as you get closer, something strange begins to happen. The stars behind the black hole start bending. Light itself becomes distorted. The universe appears warped, almost as if reality is being stretched around the darkness, and that's exactly what's happening. According to Einstein's theory of relativity, massive objects bend space and time. A black hole bends them more than anything else in existence. As you continue falling, time itself begins, behaving differently. For you, everything feels normal. Your heartbeat remains the same. Your watch keeps ticking. But for someone watching from Earth, something bizarre happens. They would see your movement slowing down, more and more, until you appear almost frozen at the edge of the event horizon. To them, it would seem as though you never actually fall in. Your image would slowly fade away, becoming dimmer and dimmer, until you disappear completely. Yet from your perspective, you continue falling. Nothing seems frozen. Nothing seems strange. You simply move forward into the darkness. And then comes the part scientists call spaghettification, a word that sounds ridiculous. But the reality is horrifying. Gravity becomes stronger the closer you get to a black hole. If your feet are closer than your head, your feet experience a stronger pull. That difference begins stretching your body. Your legs are pulled harder. Your torso follows, then your arms. Then every atom in your body. You become longer and thinner, like a strand of spaghetti being pulled apart. For smaller black holes, this process would destroy you long before reaching the event horizon. You wouldn't survive, not even for a second. But here's where things get even stranger. Not all black holes are the same. Because if the black hole is large enough, you might cross the event horizon completely unharmed. And that's when the real mystery begins. Because beyond that boundary, no human has ever seen what happens next. Let's say the black hole is enormous. So enormous that crossing the event horizon doesn't immediately kill you. Against all odds, you're still alive. You pass the point of no return, and nothing happens. No explosion, no flash of light, no invisible wall. Just silence. That's what makes black holes so terrifying. You may not even realize you've crossed the boundary. Behind you, the universe still exists. The stars, the galaxies, everything you've ever known. But there's a problem. You can never return. not because something is physically blocking you, but because every possible path through space now leads deeper inside. Escape has become impossible. Even light can't find a way out. You continue falling, minute after minute, deeper into the darkness, and then you begin approaching the greatest mystery in modern physics, the singularity. According to Einstein's equations, everything inside a black hole is crushed into an infinitely small point. Infinite density, infinite gravity, a place where space and time completely break down, a place where our understanding of reality simply stops. The laws of physics that explain stars, planets, and galaxies no longer work. It's like reaching the edge of a map where everything beyond it becomes unknown. And that's exactly why scientists are obsessed with black holes, because they may be hiding something even stranger. Many physicists believe singularities don't actually exist. Instead, they think our theories are incomplete. Somewhere inside a black hole, Einstein's theory of relativity collides with quantum mechanics, and nobody knows what happens next. One possibility is that matter is compressed into an exotic quantum state we've never observed before. Another possibility sounds like pure science fiction: wormholes, shortcuts through space and time. Imagine folding a sheet of paper. Two distant points suddenly touch. Instead of traveling across the page, you jump directly through it. Some theories suggest black holes could create tunnels connecting distant regions of the universe, or perhaps entirely different universes. Right now, there is no evidence that wormholes exist, but the mathematics allows the possibility. And if even a fraction of those theories are correct, a black hole may be far more than a cosmic trap. It could be a doorway, but the mysteries don't end there, because black holes have created one of the biggest problems in science: the information paradox. Everything that falls into a black hole appears to disappear forever. Stars, planets, gas, light, even information itself. Yet according to quantum physics, information can never truly be destroyed. Somehow, those two ideas cannot both be correct. And for decades, scientists have struggled to solve this contradiction. Even Stephen Hawking spent years changing his views about what happens inside black holes. Today, researchers still debate the answer. Some believe information is stored on the event horizon itself. Others think it escapes in a subtle form known as Hawking radiation. But nobody knows for sure, which means black holes remain one of the greatest unsolved mysteries in existence. Now imagine your final moments. You continue falling. Reality becomes increasingly distorted. Space and time twist around you. Every direction points inward. Every path leads deeper. The universe behind you fades forever. Ahead lies something no human has ever seen. No probe has reached it. No signal has returned from it. No scientist can fully explain it. And perhaps that's why black holes fascinate us so much. They are not merely objects in space. They are boundaries, the place where human knowledge ends. A reminder that despite everything we've discovered, the universe still keeps its biggest secrets hidden. So what would happen if you fell into a black hole? Would you be stretched apart by gravity? Crushed into a singularity? Transported through a wormhole? Or encounter something beyond anything we've imagined? The truth is, nobody knows. And somewhere in the darkness of the cosmos, the answer is waiting, hidden behind the event horizon, beyond the reach of every telescope, beyond the reach of every spacecraft, and perhaps beyond the reach of human understanding itself.